what is the 0D? Well, according to the Universal movie, which is what you see there, Universal movie has in a single frame only the static objects and concepts, and you need at least 2 frames of the movie to illustrate any dynamic concept. Okay, so all the ones on the bottom are dynamic concepts. You can see that they take up at least 2 frames. The one on the top take up only 1 frame. Where should we put the 0D? I mean, is this an object? Is this a thing? 0D. And, when we define the word object, we define it as, that which has shape. And so what is the shape of 0D? Is there such a monster? Okay, so that's the issue today. And so here's what the 0D looks like, okay? Get your eyes ready. Blink. That's the 0D, okay? Nothing. Okay, so this is what we're going to talk about today. Nothing. Okay, I could have painted it black also, by the way, or any color for that matter. There's nothing there. That's the 0D. 0D means that it has no length, width, or height, no size, no nothing. That seems to be the definition of space. Okay, so here's the rundown. This is the mathematicians, and they harp a lot on the word 0, or on the number 0 as they call it. If there is such a number, there's a symbol, there's a numeral, but the question is, can you count to 0? We can count to 1, to 2, to 3, no problem there. We can't count to negative numbers, to -1 to -2, right? Okay, that's an operation, that's not a counting. Counting, you can only count integers, and the question is whether 0 qualifies as an integer. Is there a difference between 0 apples, 0 rocks, and 0 trees, and 0 houses, 0 dogs? 0, 0, 0, there's nothing there. So, we start off on the wrong foot with this 0D already. So here it is. These are the mathematicians, the notions they have where they introduce 0 and 0 dimensions. Okay, you have 0 to begin with, the number 0. Is that a number? The answer is no. You can't count to 0. Okay, can't count to 0 apples. We have the coordinate system, what they call the coordinate system. And it looks like that thing on the right over there, all those numbers. Okay, what's the problem there? Well, they put 0, 0. But see, the coordinates are used to locate something. And if you're at 0, 0, what is your location? 0 location? I have 0 location. Yeah, that's great. Okay, and so no, they're not talking about 0D, 0 coordinates. Or coordinates where the number 0 is in there. They're not talking about length, width, or height. They're talking about number lines. Okay, so whenever they use a 0, it's hopefully followed by a whole bunch of integers, like 1, 2, 3, 4, 5. And they're not talking about, coordinates or dimensions or vectors. They're talking about number lines. That's why all these people see no difference between, the time dimension, as they call it, and the space dimensions, because they're not talking about dimensions, they're talking about number lines. Okay, so 0 time, how long is that? How about 0 apples? How many objects is that? Is there a difference between 0 apples and 0 dogs? Sounds like it's the same, right? So qualitatively, there's no difference. 0 length, how big is that? 0 distance, seems like the object itself. So the question is, can you put 0 time, 0 dimension, 0 length? Does that make any sense? Okay, so what do they mean by 0 dimensions? And one of the starting points we've always had is the point. Euclid told us something about the point. He says, definition 1, a point is that which has no part, meaning no dimensions, 0 dimensions, or 0 size. Exactly what he meant by that, nobody's exactly sure about it, but he meant 0. He says there's nothing there. The point is what? If it's not a thing. And if it's not a thing, if it's not a figure, if it's not a geometry, does it belong in geometry? Okay, so that's the question we have to answer. Does the point belong to geometry at all? If a point is location, it's a representation, a pictorial representation of location. Well, first of all, you can't represent a concept with an object. You can't represent love with a heart. And likewise, you should not represent location, a concept, with a dot. You should not confuse them, at least. Okay, either the dot is the point, or the location is the famous point. And so, which one is it? Is the point both? Well, when it's both, you're trying to cover both, all bases. That's what you did. Okay, you're trying to merge a concept with an object, and that's why the point fails, and that's why they can't define it to this day. But a line is breathless length, says, okay, so it's got no thickness, okay. The ends of a line are points, so we have two nothingness at the ends of a line, okay. And a straight line is a line. I like that. A line is a line. Line is a line, a line, a line, which lies evenly with the points on itself. In other words, the line is made of zero-dimensional points. For some reason, they call it a one dimension. Okay, but we're not into the one dimension, we're into zero dimension. That's what both of them look like. The point looks like exactly like a line, okay, because you cannot see zero dimensions, you cannot see one dimension. You need at least two dimensions to see something, to imagine something, let alone see it. You cannot visualize this, a 0D or the 1D. Okay, so yeah, Euclid failed us as far as defining the point, and everybody just used whatever definition he had. Okay, so he continued, he used the point as the center of a circle. So he defined it as a location, he defined it as a concept. Okay, here it is, says, a circle is a plane figure contained by one line such that all straight lines falling upon it from one point among those lying within the figure equal one another. And he was talking about some kind of wheel there, it's got all the spokes. Okay, that's what he was referring to. And he says the point is called the center of the circle. So what is a point? Point is the center. It's the location. It's not a thing. It's not a standalone thing. Okay, the point is the center. And center is the 0D, because what we're talking about is a concept. We're talking about location. Okay, so they're equated. Okay, 0D, location, center, it's all the same. It's important to know that the circle has changed over time. Okay, here's the definition that Euclid had. He says he looked at it as a bunch of spokes, and that's not what the circle is today. According to the mathematicians today, a circle is a shape consisting of all points in a plane that are at a given distance from a given point, the center. In other words, they got rid of the lines, the spokes, okay, and they just left the little dots, and they say there's a distance. Not a line like Euclid said, but a distance. Okay, so the line is the distance, or they're different, one or the other. But you can see that Euclid's circle looks a little different than Hawking's there. Okay. Anyways, yeah, the point is the center of the circle, and it's 0D. Okay, it has no shape, no size. It's absolutely nothing exactly like the 0D. Okay, it's the center. Okay, just in case, it's important to put this in here, okay? Euclid defined a figure, right? For the purposes of geometry, what is a figure? Of course, we need to know what a figure is, because geometry can't do without the figure. Okay, so he said, figure is that which is contained by any boundary or boundaries. We have a problem because the point is 0D. And so it has no boundary because it has no size, no shape. So the point, in fact, he did not define it as a figure. He did not define the line as a figure. He started defining figures starting with planes. Okay, he realized that much, apparently, that what came before, the lines and the points, he could not officially put them under figures. Okay, so he skipped that step, but then he uses the point to make every one of his figures. He uses the point to make the lines, he uses the point to make the planes, and he uses them to make the solids. What is he talking about? He's talking about location. He's not talking about point, meaning dot, meaning a thing. Okay? He's talking about a concept, location. But he's got a different, another contradiction. Here it is, okay? He says the following, he says, a boundary is that which is an extremity of anything. So a figure is that which is bound by, by boundary, and a boundary is what contains a figure. Great, we learned a lot. We have this circular set of definitions between, number 13 and 14. Okay, so yeah, we have a problem with Euclid's definition, and so it's something for you to think that we started off on the wrong foot with geometry, which was the first religion, the science they call it, okay? It was an attempt to merge math with physics, and that's impossible. You cannot merge those two. Math, first of all, is a language. Physics is a discipline that explains how this universe works, hopefully, right? And so one has nothing to do with another. It's like saying that I'm going to explain using Chinese. Well, yeah, you can use Chinese or Greek, whichever you understand better. It doesn't matter. You can use any language you want. But the explanation has nothing to do with the language, okay? In the sense that the language and the explanation do not necessarily have to merge. You can use any language to explain, okay? And so that's where we started off on the wrong foot. These people try to merge math with physics. Those two cannot be merged. Math is a descriptive language, and physics is an explanatory discipline. Okay, so physics is part of science, math is not. We don't use math in science because science is about explaining, and math does not explain. That's how simple it is. Okay, you just have to define these terms to find out where to put each one properly. Okay, so they use this term known as the singularity. Scary thing, the singularity. What is that? I mean, is this a standalone object that I can bring to the conference, or that I can maybe make an image of so that I can show the congregation out there and say, look, this is the singularity? No, I can't, because singularity is a mathematical concept. It's not a thing. It's not a physical object. It doesn't have shape, doesn't have size. Singularity is what? 0D, 0 dimensions, okay? 0 dimensional, okay? Okay, so here we have one example of that, which is the Big Bang, okay? And this is what it looks like, okay? Explodes, okay? And it's allegedly what created all the matter that we have in the universe today, okay? So we started out with this little explosion, this little dot that explodes. And that little dot, that's supposedly the singularity. Okay, so if we start out with a singularity, you would think, well, okay, there's something there. But they say that the singularity is 0D. It has no shape. It has no size. So we started out with nothing, ended up with something. They still haven't explained what the mechanism is for that event, that phenomenon to take place. How do you explain it? Yeah, they're saying that something came out of nothing, so because they start with a singularity. And okay, I'll concede the singularity. What is it? Is it a something or is it a nothing? And they define it as 0D, so we have a nothing. That's the definition of nothing, 0D. Okay, here we have a different version of that same Big Bang. Okay, it looks sideways. It's going to explode. Okay, and so we start out with this little dot that explodes and creates this sideways looking cup. Okay, the problem is, what's the black stuff? I thought that was nothing. I thought that was space. But it turns out that space is inside this glass. Okay, that black stuff inside the glass, together with the stars and everything else, time, whatever you want to put in there, that's our universe. So what's the black stuff that gives shape to this glass? So that's the issue. The issue is, if the black stuff is 0D, if that's the nothingness, right? What is the stuff inside the black stuff inside the glass, and vice versa? If the space is inside the glass, what gives shape to the glass? Okay, so the contour has to be accounted for. Okay, here we have our universal movie. Okay, so what's the issue with this? The issue is that suddenly you have something out of nothing. That's what it is. You start out the first frame of the film, hopefully with nothing, and suddenly you have something. Turns out the something is a nothing as well. That little yellow dot that you see there is really a singularity. Singularity looks exactly like the one in frame one. And so the question is that the 0D there? Okay, so that's the question. And of course, what traditional religions do is they say, well, God created the singularity. Okay, so God moved his magic wand and he created singularity, put it in the universe, and from there everything sprang out. And the mathematicians say, well, that's not really true. That's not our theory. We don't know what happened before the singularity. We don't know how the singularity came about. All we know for sure, proven, it's a fact. They say that if you take everything back, one day at a time, all the way to 13 billion years or 14 billion years ago, you end up with a singularity. And so the question is, where did the singularity come from? The religious folks say God made it, and it turns out the famous singularity is absolutely nothing and looks like the one in frame one, like nothing. So again, we end up with a bunch of nothings. I told you I was going to talk to you about nothing today, so I don't know when you're listening. Okay, they also use the singularity for the black hole. At the center of a black hole, in fact, the important part really is that singularity. What is the singularity? Well, you got to go slowly. You have a star, big star. Just think of it as a gigantic star, many times bigger than the sun. Okay, this star collapses, gradually collapses on itself, gravitationally collapses. Right, it's all pulled from the edges inwards. So much so, it's got so much matter, so much mass, so much compression going on that it turns into a singularity, meaning it turns into something that has something. That's a big word there. Something that has no length, width, or height. It has no shape, no size. That's what a singularity is. So at the center of a black hole, you have a singularity. It's a mathematical concept that has to do with mass, runaway mass, actually. And the elephant's gone, but his weight remains behind. They're going to be doing stuff with the elephant's weight. But all the matter of the elephant has been crushed out of existence. There are no more atoms. Okay, so let's understand what a black hole is. They usually try to define it in different ways with escape velocity. No, that's not what a black hole is. Black hole is a star that collapsed completely to a point, meaning 0D, 0 size, 0 shape, nothing. That's what it is. But the mass is infinite or whatever, okay? Because they don't like the word infinite when they're talking about the mass of a black hole, because if it's infinite, all black holes should be infinite in mass. And they don't like that. They have different sizes for different black holes. Okay, so this is what the black hole looks like. You've seen that. They've proven it. And so people look at that and say, okay, I know what a black hole is. No, you don't. What you're staring at is not a black hole. What you're staring at, okay, let's understand what you're staring at. You're staring at, according to them, not me, okay, this is according to them, matter falling into a black hole. Supposedly there's a singularity, a nothingness in the center of that whole circular region, and the bright stuff is simply the light given off when it passes the event horizon. That's what they claim that that's what you're staring at. So this is not a picture of a black hole, because you cannot take a picture of a black hole because it's a singularity that has no size. It's 0 dimensional. That's why you can't take a picture of a black hole. It's black anyways. It's dark anyways. So they take a picture of this and people say, okay, I see what it is. That's a black hole. Yeah, it looks like a black hole. No. What you're staring at is matter rushing into a black hole. It's like taking a picture of water going down a drain. And you take a picture of water, but it turns out the drain is 0 dimensional. You can't see, once the water is gone, you look and you say, well, where did it go? I don't see the hole. Okay, there is no hole because it's 0D. Okay, so let's understand that. Water going down a drain, that is 0D. Where did it go? And that's the issue. That's what you're staring at there. And that's what you got to explain. Where did the matter go if there's nothing there? If there's no hole? The famous hole is 0D. Okay, here you have what people think a black hole looks like. Should be the other way around. I put it white so that you would just understand the concept, okay? Not that it's a white hole or that black holes look white. No, it's that I put a dot there to show you what they have in the back of their minds of how they visualize a black hole. They visualize it as something infinitesimally small. Infinitesimally small is not 0D. It's not 0 dimensions, okay? Infinitesimally small just means small, okay? There's something still there. There's something that's got shape that if we had the proper microscope, God's microscope, would look something like that. That would be infinitesimally small. In fact, infinitesimally small means it's getting smaller and smaller and smaller forever. It never reaches 0 size. It always gets smaller. That's what infinitesimally small is. So the mathematicians like to use that term because, again, they cover 2 bases. It means something and nothing at the same time. It means that it's 0D, 0 dimensional, and at the same time it has shape because it's approaching 0 dimensionality. Okay, we got that? Okay, but this is exactly what a black hole looks like if we follow their rules. Just like that. Okay? That's what a black hole looks like. Nothing. Absolutely nothing, because they claim it's 0 dimensional, no size, no shape, etc., etc. Okay, so you say, well, Bill, you invented all this. That's not true. None of that's true. A black hole is not 0 dimensional. Okay, so at this point I need to introduce evidence, authority, okay? And I'm going to step aside and I'm going to let them talk, okay? So that you don't accuse me falsely. Okay, here it is. Okay, here's Stephen Hawking, and he says Chandrasekhar calculated. Chandrasekhar was a Nobel Prize winner, as you can see at the bottom there. Calculated that a cold star of more than almost 1.5 times the mass of the sun would not be able to support itself against its own gravity. Would it collapse to infinite density? Infinite density means no volume. Okay, it means 0d, 0 size, no shape. In fact, there it is. Eddington was shocked by that implication, and he refused to believe Chandrasekhar's result. Eddington thought it was simply not possible that a star could collapse to a point. Point, 0d, Euclid's point, no size. Einstein himself wrote a paper in which he claimed that stars would not shrink to, what? 0 size. That's what these people are talking about. And they gave the Nobel Prize to Chandrasekhar for proving that a black hole is 0 size, okay? And then we have this other gentleman. He's from a university, and he says, on solving the equation with a particular value of central density, you will get a model of a star with mass m and radius r. Plot r as a function of m and show that r falls to 0. Falls to 0. The radius falls to 0 when m is equal to the Chandrasekhar mass. Okay? So what are we talking about? Radius of 0. There's nothing there. 0 dimensional, 0 size, 0 shape. If you can do all these, then you have repeated the calculation for which Chandrasekhar won the Nobel Prize. So, what did the mathematicians prove and give Nobel Prizes out for? For proving that a star collapses to 0 size, and all that remains behind is its mass. Infinite mass, or because it's got infinite density, right? Because it's got 0 volume. That's why it's infinite mass. Okay, so this is a mathematical calculation. Okay, and again, let's introduce more evidence because people say, well, that's just Stephen Hawking. What did he know? Okay, let's go with another one. It says the black hole's radius is 0. One person. Another fellow says the point of 0 volume and infinite density. Okay, creating what is known as a singularity. What is a singularity? 0 volume, infinite density. That's what a singularity is. 0d. Okay, we're talking about the 0 dimension. We're at the 0 dimension. But you might say, well, that's just 2. Okay, let's find out some more here. 0 size, up to a true mathematical point. Another person says, collapses totally, talking about a star, right? To a singularity, which is what? A point which has 0 radius. Okay? It is impossible to see a singularity. No kid. Gotta have good eyesight to see nothing. Okay, so just in case other people rub it in from a different point of view, but say the same thing in different words, they say that a black hole crushes all matter out of existence. There you have 3 references. You can look them up. Okay, all these people believe that the star, okay, known as a black hole, gigantic star that is collapsing under its own weight, under its own gravity, collapses to 0 size, crushing all matter out of existence in the process, so that eventually they end up with a singularity, which is 0 dimension, 0 size, no shape. Okay, so let's understand what we're talking about when we talk about 0 dimensionality, Big Bang, and black holes, especially those 3, right? Okay, so this is what it looks like. Okay, you see the star. Okay, think of this as a star, a gigantic star, and over time it collapses to nothing. Okay, so it doesn't end up with a point. It crushes all matter out of existence and ends up with nothing, with 0d. And until you get that through your skulls, you're going to have a trouble understanding what a black hole is and what kind of BS they're trying to sell you, okay, the mathematicians. To them it makes sense because they just deal with numbers. To a physicist, it makes no sense whatsoever. So if you're a physicist, if you're a rational individual, you're going to reject this notion of a black hole, okay? Okay, so what's the problem with what they're saying? Well, they have all this matter, right? They're going to crush it out of existence. Okay, turn it into 0 size, infinite density, no shape. Okay, and so here it is. We have a little circular argument there because a black hole is made out of mass, right? But mass is the quantity of matter. That's how it's defined. So we say, okay, a star has all this matter, the quantity of matter, that's what we call the mass. We measure it in kilograms, but kilograms is a measure of how much matter the star has. Okay, a gigantic star, millions of times bigger than the sun. Great, no problem. Okay, so now this matter, because of its own weight, because of its own gravitational attraction towards its center, it's collapsing in on itself. So it's collapsing, compressing everything in there until all matter disappears. All matter disappears. Okay? So it crushes all matter out of existence. We have no matter, but they say the mass remains behind. They crushed the elephant out of existence. Not a single atom remains, but the weight of the elephant, is still there and is causing all kinds of problems to stars or whatever's out there. So we have a contradiction, because if mass is the quantity of matter, that's how they define it in this context, right? And if that's what mass is, the quantity of matter, we crushed all matter out of existence, how do we still have mass? That's the issue. So they have a contradiction. They have a circular argument. Okay? These are things you got to keep in mind. Okay, so it's funny because here we have NASA. And what does NASA do? Well, NASA talks about the sizes of black holes. Okay, and I don't know how you can imagine this, because if a black hole is a singularity has no size, what sense does it make to talk about sizes of black holes? And this is a video that you can look up at NASA. It came out recently. Here it is. I'll show it to you. Yeah, I'll show it to you in fast motion because they show it in slower motion, but here it is. And they're talking about sizes here, okay? You can see that they're just zooming out, and they're eventually going to show the biggest black hole in the universe, which is bigger than all this combined. That's what you're staring at. Okay, so ton 618 is bigger than all that stuff that you just saw. That's what they're saying. That's how big this black hole is. So what are they talking about? Let me show it one more time so that if you missed any part of it, you can see it again. What are we talking about? We're saying that we have this black hole which is bigger than several galaxies put together. That's essentially what they're saying. And it's this ton 618. Here it goes again. You can see our little sun there compared to the solar system first. And then you have other galaxies nearby. And this thing, this black hole, they say is bigger than all of them put together. Milky Way, there you have, Andromeda. And with all that, this gigantic black hole is bigger than all of that. How can that possibly be if a black hole has zero size? In other words, a singularity. What are they talking about? Okay. Well, when they talk about sizes, they're not talking about bigness like shape. They're not referring to shape. They're referring to mass. So when they talk about size, they use it in terms of mass, not in terms of shape. So when you talk about size, size of an elephant, you're saying, well, this elephant is bigger than that one. What? You're talking about the shape. You don't say, well, because if you're going to talk about weight, you say, let's weigh them, and say, well, this one weighs more than that one. That's not what they're saying. Or has more mass than that one, more atoms. Yeah. But that's not what they're saying. They use the word size. They give you an idea, or they try to convey the idea that they're talking about shape, that this one has a bigger shape than these other things. That's what they're saying. Okay? And so here you have one individual, and he says the following. He clarifies to us. He says, talking about black holes in terms of size is inherently perilous, mostly because of gaps in language. We talk about things like size when they don't really apply because we don't have a better way to describe them. Absolutely a lie. We have a way of describing them, but they want to use the word size in the wrong context on purpose to mislead you and to mislead themselves. They're not talking about size. They should simply talk about more mass or weight or whatever they want to talk about in mathematical terms. They're not talking about size. They are deliberately misleading you and misleading themselves when they use the word size. The true size of a black hole, even the largest, is impossibly small. That's kind of their whole deal. Even the most massive black holes are, in fact, quite small, just singularities in space-time, which harbor so much mass, they'll happily swallow anything and everything that comes into grabbing distance. When we talk about the size of a black hole, what we're really talking about is the diameter of its what? Event horizon. And those can reach truly incredible sizes. Okay, so they're talking about the region of influence of the singularity. Okay, singularity is zero size. If it's zero size and has no matter, then it has no influence over anything. But they created this campfire notion. Okay, it looks like this. Okay, when you're in a campfire, okay, you're sitting around it, you have this fire going on. But the fire isn't just constrained to where the wood is. You know, the campfire really extends, the heat extends way beyond you. So you can think of as the fire as being the zero-dimensional singularity, if you can turn that into a 0D. But the important part here, when they're talking about size, they're talking about the region of influence, so to speak, the heat of the campfire. Okay, so the region of influence and how far it extends is what they call the event horizon. And that's when you have this escape velocity issue. Okay, so they call the black hole the whole thing, not only the singularity at the center, but also the region of influence. And that is what is so misleading about what the mathematicians do, because they're not really talking about physics, they're talking about a region of influence of something which has no size, no matter. How can that affect anything? It's again the case of the water running down a zero-dimensional drain. Once the water's gone, you say, well, where's the hole? Well, there is no hole because it's zero size. And zero size means you still have the sink and no drain. You have forgot to put the drain in there, but the water rushed through there. That's what they're trying to sell to you. Okay? And they use words like infinitesimally small instead of saying the correct word. Zero size, zero dimensions. Okay? And yeah, so you'll see infinitesimally small. They crush it out of existence. They use those terms. And what they're talking about really is the vacuum, nothing. Okay, we're talking about nothingness throughout this whole thing. And so, what is the 0D? Well, 0D is absolutely nothing. It's the point, which is simply a location. Location is not a thing, so you can't talk about dimensions in terms of location. Okay, location has no dimensions. Okay, so I don't know why they call it the zero dimensions, the point, or zero dimension. It's also a synonym of singularity. What is a singularity? It's what is the center of a black hole, and it's what gave birth to the universe. Maybe in the Big Crunch we end up in another singularity. Okay, so they use all these terms, and what are they talking about? They are talking about nothing. That's what the 0D is. Zero length, that's absolutely nothing. What's zero time? Absolutely nothing. What is zero apples, zero trees, zero rocks? That's absolutely nothing, and they're all equal. So they like the zeros, okay? But zero means absolutely nothing. You can't count to zero. So 0D, to summarize, is nothing. And so this whole time I've been talking about nothing.